to the fourth and final part of Volvo 240 fuel system repairs. This is for my 88 LH 2.2 fuel injected Volvo 240. So we've pulled the tank, we've cleaned the tank and reinstalled the tank. We've pulled the main pump and replaced and reinstalled the main pump. And the last order of business would be to replace the lift pump or the in-tank pump that goes inside the gas tank and feeds the main pump. Access to the in-tank pump on the 4-door sedans and 2-door sedans is in the trunk. Open the trunk and it's under the carpet underneath the speaker tray. And for the wagons, it's in the hatch area underneath the storage compartment. You'll have to remove the entire panel to access it easy. I have already pulled the unit we're just gonna go ahead and replace that and stick that back in, and then everything should be fresh. So here is the fuel sender that I pulled from the fuel tank before I cleaned it, and it's not in great condition. The pump is obviously dead. The strainer was missing, and there's some wiring problems as well. So this is the ground wire for the fuel pump, and you can see it's fully exposed. So this is something we're going to have to replace. I think I was in the tank not too long ago, several years ago, and so this tube here, this transfer tube for the pump into the rest of the fuel sender, it is replaced, and it's replaced with a high quality fuel submersible fuel line. So if this cracks on you, or you see any sort of breakage, you want to replace it, and it has to be a fuel submersible fuel line. Otherwise, once you get into the tank and it's sitting in there, it'll start to expand and come apart inside the tank. So yeah, it's been a few years and it's held up good. I don't see any sort of leaks there. I did go ahead and at that moment, I had replaced the in-tank pump too. So this is an upgraded unit from a Volvo 740 Turbo, and it pushes a little bit more fuel than your stock 240 in-tank pump. And the whole reasoning behind that is that you want the main pump to be working as as little as possible. So the more fuel that gets fed to the main pump, the less fuel that the main pump has to be actually sucking, and the more time it can spend just shooting fuel to the engine. So yeah, it's a nice little upgrade. It's not much more expensive. I think it's actually maybe even the same price as a 240 in-tank pump. So I'm going to go ahead and start off with taking off the retaining ring for the fuel sender. Get that out of the way, and I'm going to take off this O-ring as well, and this is what seals the sender to the tank. And I'm just going to move it down past everything. This is the OEM unit. It's you can tell it's been flattened out a little. I've used aftermarket stuff, and as soon as it comes in contact with the fuel vapors, it expands and it won't seal. So I just reuse these mostly, but we'll clean that up, put it off to the side. And then just to give you a quick rundown, these are the 3 wires that come from the fuel sender. So your black wire here on this 2-prong connector, that's going to be your power wire, 12 volts from the fuel pump relay, and that's going to power the fuel pump and have it start going. Your brown wire with a ring terminal, that's grounds to the body of the car in the trunk, and that grounds the entire fuel sender. And if you trace it back into here, it just grounds into the sender, and then which the fuel pump grounds also into the sender, so therefore grounds the pump and lets it run. And then the last wire is this gray wire here. The gray wire is actually to your fuel level sender. So you trace it back in, there, and you'll find that it comes out into this, let's see, it comes out into this blue little wraparound wire, and that goes over to the fuel level gauge. Moving on, you're gonna need a Phillips screwdriver. You want to start off with taking off the grounding strap. And then also you can slide the cradle off of the assembly as well. Here's just kind of I guess it's I'm not sure what that is, some sort of clip that is threaded on the other side. But once that's off, you can see that the plastic cradle will just slide out. I've seen several variations of this, but yeah, that comes out. And then now your pump can kind of move around a little. Next step would be to take off these worm clamps that are holding the transfer tube to the pump, and that will help give me access to the actual terminals, in which looks like they are 1/4 inch. The different pumps will have different nuts that come with the terminals, and these just happen to be 1/4 inch. Also, it's important to note the orientation of the worm clamps here. You know, you just want to put it in a position to where you can access it and tighten it later on. You know, it's not facing the other way, it's not blocking anything like that. And also to keep track of the orientation of the bulb in case you knock it out or something. And so you can tell that on the armature, it is facing to the right. Okay, so the pump is free from the transfer tube now, and then we can access the nuts from the top side. All right, so the tank pump is free from the sending unit. I would just go ahead and stick this over here, and these are all the pieces that go along with the tank pump. Should have 2 split washers, 2 nuts, and then you have the 2 Phillips screws that go with for the mounting and the ground strap. And then I also have this nut and square nut and screw for the worm clamp. But so yeah, when I was taking it off, unfortunately, this little connector piece broke off of the terminal for the powers the pump. So it looks like we're gonna have to replace this harness. It's not the end of the world. You know, everything is soldered in to the bulkhead connector that's at the bottom of the sending unit. So we're just gonna have to do a little soldering, but it's probably for the best, because you can see that the power wire has it's starting to show some cracks in the insulation as well, and pretty soon it probably would have ended up like this ground wire anyways. So we've got this radio suppression piece opened up. You just take a flathead and pry down on the little clips, and as you can see, oops, it's just a coiled wire at the end of the power wire. So it goes in, it's just coiled. You can uncoil it, but it just sits in here and it's fully exposed to the gasoline. Here's the other side for the ground wire. You can tell it's got a lot of corrosion in there as well. But yeah, so either way, the ground wire would have had to be replaced, and the power wire as well. So, you know, we will not likely be returning this back into the fuel sender assembly. We'll just go ahead and delete that and run fresh wire through it. So I've just removed the power lead from the bulkhead, and I'm gonna go ahead and clean that up. So what I've done is I've cut the wire, the new wire, to be the same length, actually just a little bit longer than the lead wire, and I have soldered on these ring terminals. And these are just your standard ring terminals that come like this, and you can pull off the jacket. The jacket, I'm pretty sure, it's a PVC based jacket, and I'll get into that in a minute and why we don't want that on there. But I've crimped and soldered them on. This is for the lead wire. The other side is going to be soldered to the fuel sender, and the ground wire, and this is the replacement ground wire. They're both the same color, but you know, I know where they're going to go. Anyways, so I just wanted to talk a little bit about the type of wire that I'm using. So like I said, these are just regular tin copper ring terminals. I've crimped and soldered on. The wire themselves it's a TXL, and what that is, it's a cross-length polyethylene jacket or insulation on there, and that should withstand the gasoline, since it's going to be sitting in the gas tank most of the time. Your standard box chain stores and whatnot is going to sell you primary wire, which I believe it's just GPT wire. It's just general purpose thermoplastic, or it's PVC based, and PVC, my understanding, is not supposed to hold up to gasoline very well. I have used a GPT wire in the past in fuel tanks, and I haven't really seen much of an issue. Like I've shown before, the jacket, even if it does deteriorate, it's not much of an issue, just because, you know, all the wires are technically exposed anyways. The only thing is that you probably don't want the wire, even though everything is in the gasoline, you don't want the wires touching each other and shorting out. But they're also the same length, so that shouldn't be an issue anyways. It's just one of those things that, you know, if you have that wire on hand, TXL is what I would go for. It's made for that kind of situation. But if if you're stuck, you have to get your car running, regular primary GPT wire is probably going to get you out of a pinch. Everything does go through the bulkhead in the fuel sender anyways. So, you know, I think it's okay, but I just want to mention that's the type of wire I'm using. Probably not my best soldering job, but solid. It'll hold. And you know, I'll let you know if things don't go well. I'm just gonna go ahead and assemble the rest of the fuel pump onto here, and we'll be ready to put this into the tank. Alright, for the pump, I went with a AirTex unit. I've had luck with these in the past. Let's see here. And just a basic strainer, just a cheapo one. Yeah, this should come with all the hardware. Again, I went with the 740 turbo pump, so it's going to be a little bit bigger than your standard 240 fuel pump, but my fuel sender has already been modified. You do have to shorten the supply line for that, but yeah, it's same size, same hookups. Yeah, everything looks the same. I'll probably put some leads on this to a 12-volt battery just to test it before I put it back in the car. But yeah, everything looks correct. Okay, so here it is. I believe this is the correct orientation. We have the float, and then the drain tube, and then the strainer that's sticking out towards me. I've tested all the connections, solder is holding up, everything works. Looking good. I just have to put it into the tank, and hopefully this will get the car running. So this is actually a homemade tool that my dad made. It's just made out of fencing post, and he cut notches into it so it fits into the teeth for the locking mechanism, and then you just put 2 screwdrivers in to torque it in place or to loosen it. But this is what I use to take the in-tank pumps out, and I've used it probably several dozen times. And then this is just a cap, I think it came off the tea kettle, to cover up the tank whenever I have stuff out. Just, you know, they make specialty tools to actually get that that locking ring out. But you know, you can get creative as well. Unfortunately, it is nighttime now, so we can't really get a good view of what's going on. But I'm ready to put the fuel sender back in here. So I'm gonna take off this lid, and then I'm also going to, yeah, I can do that later. So let's drop the fuel sender in first. Before I do, I like to lubricate up the O-ring with some petroleum jelly. That way it doesn't squish. Just need to scooch the lines out of the way. I'll slowly locking ring in. Okay, so here's the in-tank pump all in there. I just gotta slide the cover back on and Just make sure the grommet's up there, put in the 2 screws, plug in your connectors, and you should be good to go. So I've done that repair dozens of times, and it's always a struggle to get the float ball and the strainer in at the right angle. So that wraps up all the fuel system repairs that I needed to do on the 88-240. As you can see, it's running good. Both fuel pumps are working. The tank's clean. I've got a fresh tank of fuel in there, and everything's good so far. So thanks for watching all 4 parts, or whatever parts you needed, and hopefully it was helpful. If it was and you enjoyed it, please click like and subscribe, and I will keep you updated on some future 240 projects. Thanks.